Hi, and welcome to 1.5 Vector Components. In this lesson, students will be able to resolve vectors into their components. So dividing scalars is something we've done for a long time. It says a group of 5 students make a 10-minute presentation. If they all talk for the same amount of time, how long does each student talk? So you do 10 and you divide that up by 5 into 5 different parts and you get 2 minutes. Oops, don't forget to write your units. Remember your units. We can divide vectors much like we divided the scalars, but instead of calling it dividing the vectors, they use a fancy term. They say we resolve the vectors into components. You're kind of doing the same thing. Instead of splitting the 10 minutes up into 5 different parts, you're splitting this one vector into its x and y parts, or the x and y components. Now, if you were looking at this vector right here, would you say that this vector is pointing up or down? There's a portion, would you say it's pointing more up or more down, right? So it's more pointing up. And would you say it's more pointing to the left or more pointing to the right? It's more pointing to the right. So in physics, and math, what we like to do is quantify how much up and how much to the right. All right, and we do that by resolving it into its x and y components. Do you remember the x-y graphs from math? Was the x-axis horizontal or vertical? The x-axis is horizontal, and the y-axis is vertical. So we can break this up into its x and its y components, and then we could say how much of that vector is pointing to the right and how much of that vector is pointing up. Those are the two different parts of the vector. So let's do an example. It says vector A has a magnitude of 12 units and its direction is 30 degrees above the x-axis. So that's right here, or north of east. Calculate the x and y components of this vector. So the x component, the first thing you always do in physics is you draw a picture. So let's draw the x-axis and the y. So we have the x component here and the y component here. Let's start by finding the x component. So again, we just made a right triangle and we're solving for this side of the right triangle. And what do we have? Now we have the hypotenuse and an angle. And what is that x? Is that opposite, adjacent, or hypotenuse? The x is adjacent. So we have adjacent and hypotenuse. Are we going to use sine, cosine, or tangent? We're going to use cosine. And we'll plug in our numbers. And when you cross multiply, you get x is about 10.4 units. So it's pointing 10.4 units to the right. How much of it is pointing up? What is the y component? Well, y is opposite that angle, and we'll use the hypotenuse again. We could use this one, but we rounded that, so it's better to use the unrounded number. So we have opposite and hypotenuse. Are we going to use sine, cosine, or tangent? We're going to use sine. We'll plug in our numbers, and we'll solve by cross multiplying. And you get a y component of 6 units. And that's all you get. So those are the x and the y units, components of that vector. Let's do a practice. Why don't you try this one out? You can pause the video, read the question. It says vector B has a magnitude of 34 units and its direction is 60 degrees above the negative x-axis. So the negative x-axis points to the left, right? If we're going to draw our x and y axis, this is y, this is x, this is negative x, this is negative y. So that's just the term, 60 degrees above the negative x-axis. Calculate the x and y components of the vector. So I'll pause the video here and then I'll show the work. So pause the video and do the work, and then I'll show you the answer. The first step is to draw yourself a picture. So you want to make sure you draw on the x-axis, or sorry, I keep on saying x-axis. The x component is right here, and the y component is right here. See how they're still head to tail? The components add up to this. This is the resultant of the x and the y component. It's like the reverse of what we have been doing in the past. So now that we have a nice picture here, we have a right triangle, and that'll give us a better gauge of where to start. So if you needed that head start and you think you know where to go from here, pause the video and try it out. So pause the video, do the trig. Let's find the x-axis first. Okay, so this is adjacent, and they tell you the hypotenuse. Adjacent and hypotenuse, we're going to use cosine. We'll plug in our numbers, and when you cross multiply, you get x is equal to 17 units. So now we can find y. Y is opposite this angle, so we have opposite. And we didn't round that x, so we could use the x. Well, you could use opposite and adjacent, use tangent. But I kind of like to do the same process every time to keep it simple. So we'll use the hypotenuse and the opposite. Are we going to use sine, cosine, or tangent? We're going to use sine. Plug in your numbers. And when you cross multiply, you get y is equal to 29.4 when you round it. Units. So now you know how to resolve vectors that are at any angle. As long as you know the angle and their magnitude, you can resolve them into components by just drawing a right triangle, calling it x and y, and then depending on where the angle is, use cosine or sine. That's a big messy picture, but that's the idea. Always start by drawing a picture. It makes it a lot easier. I highly recommend making a picture of the right triangle. That'll tell you where to go. And that's about it for vector components. It's really just more trig stuff, and it's kind of like going in the reverse. So now you have the hypotenuse, and you're trying to find those two legs. So give it a try in the 1.5 vector components practice. Have a great day.